This chem catalyst is on mole-to-mole calculations. And before we get started here, I'm getting a little hungry. That's right. I think I might need a little guacamole. Anyway, the question we want to answer in today's chem catalyst video is this question, which is, how can we determine the amount of product from a chemical reaction? So if we look at these chemical reactions here, like calcium chloride and sodium carbonate, producing calcium carbonate and sodium chloride, we want to figure out, well, how much of sodium chloride could we make? Or how much calcium carbonate could we make if we were given amounts of these reactants? All right, now I haven't given specific amounts yet because we need to talk about mole ratios. So coefficients in a chemical equation stand for the numbers of moles of reactant or product. So if I'm going to read this chemical equation, it says that 1 mole of calcium chloride combines with 1 mole of sodium carbonate to make 1 mole of calcium carbonate and 2 moles of sodium chloride. Down here we've got 1 mole of copper sulfate with 2 moles of sodium hydroxide makes 1 mole of copper hydroxide and copper 2 hydroxide and 1 mole of sodium sulfate. So what we can identify here are these things called mole ratios, all right? And mole ratios are the proportions in which the substances, both products or reactants, combine. So if I look at this mole ratio, this would be a 1 mole of CaCl2 to 1 mole of Na2CO3. Be a 1 mole to 1 mole ratio because these both have coefficients of 1. However, if I wanted to look at the mole ratio of, let's say, calcium chloride and NaCl from this equation up, same equation up here, but I would have 1 mole of calcium chloride and that would produce 2 moles of sodium chloride. So that's what that says. Every 1 mole of these would make 2 of these. So essentially, if I put 2 moles of calcium chloride in, I'd end up getting 4 moles of sodium chloride out, because for every 1 mole of calcium chloride, there are 2 moles of sodium chloride produced. All right, let's first off start by looking at trying to identify some mole relationships. So I'll do the first 2, and then I'm going to have you do 2 on your own. So calcium chloride to sodium carbonate. Okay, well, let's find out here what I want. Calcium chloride here and sodium carbonate here. Okay, so these are both reactants, which is fine, but the coefficients are a 1, so it's a 1 to 1 mole ratio. All right, now over here, let's take a look at sodium carbonate and sodium chloride. So sodium carbonate is right here and sodium chloride is right here. So that's a 1 to 2 mole ratio. Now go ahead and identify the other mole ratios. Press pause because I'm going to go ahead and do it, and then check in to see how you've done. Well, this mole ratio, I've got NaOH here and copper hydroxide here, is 2 to 1. And this mole ratio here, copper sulfate to sodium hydroxide, is 1 to 2. All right. Now, why on earth would we want to figure out mole ratios? So we've got to go back and remember the question. The question for today was, how can you determine the amount of product from a chemical reaction? So let's look at that. We want to use mole ratios in the equation above to calculate the following. Okay, moles of FeOH3, so FeOH3 produced when 5.2 moles of NaOH react. Okay, well, let's look at our mole ratio. Our mole ratio here says that 3 moles of NaOH produce 1 mole of FeOH3. So if I'm going to solve this, what I do is I start with what I'm given here. So I go, I'm given in this case 5.2 moles of NaOH, and I use the mole ratio that 3 moles of NaOH, that goes downstairs. I want to cancel that. That will cancel with that. And then 1 mole of FeOH3. FeOH3 on top. And so my answer here is 5.2 divided by 3. So I get 1.7 moles of FeOH3. Pretty simple. That's how I use the mole ratios. Now then for 2, I'm going to go back and identify my mole ratio. So I want to know the moles of NaNO3. So that's over here. Let's switch colors real quick. That's over here. NaNO3 produced when 5.2 moles of NaOH. So this is a 3-to-3 ratio. Well, 3-to-3 is really just 1 mole to 1 mole here. So this becomes pretty easy. If I write it out, it's kind of a lot of work for this problem, but if I say I have 5.2 moles of NaOH, and again, my mole ratio is, I go up here just a little bit, you can see that it's 1 to 1. 3 to 3 is 1 to 1. So 1 mole NaOH, 1 mole NaNO3. And then I'd end up with 5.2 moles of NaNO3 because the NaOH would cancel out. So for the last one here, it says the moles of iron nitrate used up. Okay, so this is interesting. I'm actually looking at a mole ratio that's right here. So in this case, I'm going to be looking at this ratio between these two. So in this case, it's going to be 3 moles to 1 mole because that's a 3 and that is a coefficient of 1. Well, it's still pretty simple to solve. I start off with 5.2 moles of NaOH again. Then I multiply by this conversion factor, the mole ratio, which is essentially that 3 moles of NaOH will require 1 mole of FeNO3, and I end up getting 5.2 divided by 3, which is the same as in the first one, 1.7 moles of FeNO3. Time for your own practice. I want you to finish this checking question. So go ahead and press pause and then solve it, and then check for the solution. So I want to know how many moles of silver phosphate, so here's my silver phosphate right here, are produced when 2.5 moles of silver nitrate react. So I'm going to put 2.5 moles up here because that helps me know what I'm dealing with. My mole ratio here is going to be 3 to 1. So my solution is to start with what I'm given, which is 2.5 moles of AgNO3, and then multiply times the fact that 1 mole Ag3PO4, which is my silver phosphate, over 3 moles of AgNO3, because this will cancel with that unit. I get 2.5 divided by 3, and I end up with 0.83 moles of Ag3PO4, and that is my final answer.